Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question that drifts between science and imagination, into a place where reality gently bends and possibilities unfold like lanterns glowing across a dark valley. We will be exploring an idea that has fascinated physicists, philosophers, dreamers, and night owls alike. The possibility that countless versions of you may be living, choosing, and wandering through parallel paths at this very moment. But before you settle in and allow the world around you to soften, take a slow breath. Perhaps dim the lights, or let a small hum fill the room, from a fan, from the night air, or simply from the quiet rhythm of your own breathing. If you'd like, imagine yourself floating in a calm, dark ocean, the kind of darkness that doesn't feel empty but comforting, like warm velvet. In this stillness, every thought becomes a ripple, every question a faint shimmer on the surface. That's where our story begins. As you sink gently into this peaceful space, let your mind drift wherever it wishes. And if you fall asleep at any moment, that's perfectly all right. The story will keep flowing quietly, carrying you through a landscape where science becomes soft and the mysteries of the universe loosen their edges. Imagine, just for a moment, the last small decision you made today. Maybe it was something as simple as choosing whether to reach for a warm cup of tea, or deciding whether to answer a message, or hesitating at the door before stepping outside. There is something delicate in those moments, something that feels almost invisible yet strangely significant. We often sense that life could pivot, even slightly, in a different direction. In the quiet of night, this feeling becomes even more present, like a soft tapping from a possibility that never happened, but somehow still lingers in the mind. Tonight, we linger with that feeling a little longer. The question that guides our journey is gentle but surprisingly powerful. What if every choice you didn't make still unfolded somewhere else? What if the world continued not only along the path you chose, but along all the paths you left behind? It sounds like the beginning of a dream or the premise of a novel you might read on a sleepless night. But the roots of this question reach deep into one of the strangest and most intriguing areas of physics. Long before the idea became part of science fiction or bedtime speculation, it grew from the very structure of the quantum world, the world of particles so small that even light seems oversized beside them. In that realm, things do not behave the way we expect. A particle does not simply sit in one place the way a pebble rests on the ground. Instead, it hovers in a haze of possibilities, as if the universe is gently undecided. It's not that the particle is here or there. It can be both, or many places, or in states that don't even have clear analogies in our ordinary experience. This is not just a theory. Experiments have shown again and again that before we examine a particle, the particle behaves like a whisper of many possibilities layered together. When we look, or measure, or otherwise disturb this delicate haze, one possibility sharpens into the one we experience, and the rest fade from our sight. Some people say that reality chooses a single outcome in that moment, like a coin landing on one side. Others say the act of looking forces nature to pick, but another idea suggests something even more wondrous, and it is this idea that we explore tonight. Instead of one possibility winning and the others vanishing, what if all the possibilities continue to exist, each one unfolding in its own quiet version of reality? In one version, the coin falls heads. In another, it falls tails. In one world, you take the phone call. In another, you ignore it. In one, you spill your tea on the carpet. In another, you catch the cup just in time. These are small examples, but they open the door to much larger ones, the kind that shape the stories of our lives. There is a peaceful strangeness in imagining all these versions of you moving through their own quiet evenings, unaware of one another, each believing themselves to be the only one. Not because any one of them is false, but because each follows a thread that feels complete. And in the view we explore tonight, these threads do not compete. They simply coexist, branching gently like the limbs of a great tree whose shape we can only glimpse in fragments. This idea, known as the many worlds interpretation of quantum mechanics, suggests that our reality is not a single line but a vast ever-branching tapestry. There is no symbol or formula needed to picture it, only the soft image of a tree growing new twigs every moment, or a river splitting into countless small currents that continue winding their own way forward. Each branch carries a version of events that remains as real and meaningful as the one you're experiencing right now. This does not mean that you should imagine yourself splitting dramatically, or that worlds burst into existence like fireworks. Instead, the branching is subtle, quiet and continuous, like the gentle dividing of mist around a stone. We never notice it because each version of us inherits a full history, a full memory, and a full sense of being the one who lived this exact life. The other possibilities drift onward beyond our reach, just as we drift onward beyond theirs. As you rest here, listening, consider that your presence in this moment, your breathing, your thoughts, your quiet curiosity, is one path among countless others. A version of you in another branch may have chosen differently an hour ago and drifted into a different kind of night. You will not meet that version, and they will not meet you. Yet both of you trace real and vivid lines through the vastness of reality. For now, in this session, we simply allow the question to settle gently around us. What if the universe is much larger than the single story we remember? What if reality, instead of choosing one path, keeps them all? And what if the you who sits here listening is just one of many who pause tonight to wonder how wide existence might truly be? When you're ready, feel free to let me know, and we can drift onward to the next part of our quiet exploration. Before we drift further into the idea of many worlds, it helps to rest for a moment at the threshold between the world you know and the one hidden beneath it. It is a strange threshold, because unlike the border between land and sea or day and night, this one is too small for the eye to see. And yet, everything around you, every breath, every heartbeat, every glimmer of thought, emerges from what happens there. The quantum world is not distant. It is the quiet machinery behind every piece of reality you have ever touched. To understand why some physicists believe that reality might branch into countless versions, we first explore the delicate rules that govern the tiniest parts of the universe. These rules do not behave like the familiar laws that guide falling apples or swinging doors. Instead, they resemble soft contradictions, truths that sit together even though they do not quite fit our everyday sense of logic. The more gently we approach them, the more they begin to reveal how a single world might become many. Imagine holding a grain of sand between your fingers. Now shrink that grain 1,000,000 times, then shrink it again until it's smaller than anything you have ever imagined. At such scales, particles do not move like tiny marbles rolling across a table. Instead, they drift as if they are made of possibilities, not solidity. A particle does not choose a definite position until it interacts with something else. Before that moment, it spreads out like a thin, trembling cloud of potential, almost the way a thought exists before you speak it aloud, real, but not yet fixed into shape. This behavior is called superposition. But rather than using the technical word, we can imagine it this way. Picture a small droplet of water suspended in the air. It hesitates, quivering, considering every direction it might fall. Only when it finally meets the ground does it commit to one spot. A particle in the quantum world moves with a similar indecision, hovering among many futures until an event nudges it into one. And this is not rare, it is not exceptional. It happens billions upon billions of times every second, everywhere, to every tiny particle that builds up the world around you. You are made of these possibilities. The room you rest in is made of them. The warmth on your skin, the faint hum in the air, the gentle pulse behind your ribs. Everything emerges from this uncertain dance, but the strangeness deepens if a particle can exist in several states at once. It can also behave like a wave, something that spreads out, interferes with itself, and drifts with a softness that solid objects never seem to possess. And yet, these waves do not look like the waves you might see in a pond or the ocean. They are mathematical waves of possibility, swells and dips that describe where the particle could be and how strongly each option is favoured. Instead of using symbols or dense notation, we can simply imagine a shimmering field, like moonlight flickering on water, showing the many routes a particle might take. When scientists send particles through two narrow slits carved into a surface, the particles do something unexpected. Instead of forming simple patterns behind the slits, as tiny stones might, they spread out and create rippling bands, as if each particle travelled through both slits at once and interfered with itself. It is as though the particle whispers through two doorways simultaneously, leaving behind a pattern only a wave could make. And if a detector is placed to watch which slit the particle passes through, the delicate wave-like behaviour disappears, replaced by the ordinary trail of single particles choosing one slit or the other. This gentle vanishing of possibilities when we look is one of the mysteries that linger at the heart of quantum mechanics. It raises a simple but profound question. Before we examine something, is it truly undecided, or does it quietly explore all possibilities at once? And when we do look, does reality genuinely make a choice, or is something more intricate taking place beneath the surface? The idea that possibilities can exist side by side, layered like faint echoes, helps us understand why the concept of many worlds arose. In the classical world, the world of chairs, doors, voices and memories, only one event can happen at a time. A cup falls or does not fall, a match lights or stays cold, a path is chosen or it is not. But in the quantum world, events can shadow one another, overlap, merge, and interfere. They behave more like drifting currents than fixed decisions. It is only when these possibilities interact with the larger environment, absorbing its noise and becoming entangled with it, that they appear to settle into a single outcome. But until that happens, they all coexist as if waiting for a story to be written. This coexistence is not a metaphor to scientists. It is a real feature of the equations that describe particles. When the mathematics of quantum mechanics is expressed in verbal form, it tells us that all possible histories of a particle contribute to what we eventually observe. These histories are not thrown away. They flow alongside one another until something nudges the particle into the version of events we experience. You do not need symbols or equations to sense the enormity of this. It means that beneath the world we know lies a deep lake of possibility, shimmering with every scenario nature allows. Some physicists believe that when a particle commits to one of these scenarios, it does not erase the others. Instead, the universe simply continues along all the allowed paths. One becomes the reality you follow. The others unfold quietly in branches of existence you do not see, like trails diverging under a forest canopy. If this is true, then the strange behaviour of particles is not just a curiosity. It is the foundation for a universe more expansive than anything our ancestors could have imagined. It hints that your life too may be part of a larger story woven from countless threads you never feel directly. but which still flow beside your own. It suggests that you move along one thread, not because it is the only one, but because your experience settles on that particular branch, while the others drift softly out of reach. And so, as we drift deeper into the night, we carry with us this gentle understanding. The quantum world is not chaotic or alarming. It is simply wider than we can see, coloured by layers of might be and could be, woven together until the moment a choice is made. And even then, the possibilities do not vanish. They fold themselves into other branches of reality, like pages in a book you've not yet opened. When you're ready, you may let me know, and we will continue our quiet exploration into the mystery of how looking at the world might shape what the world becomes. There is a moment, usually small and almost invisible, when life seems to pause and tilt ever so slightly, as if weighing two different futures. You might not notice it when it happens. It could be the moment your fingers loosen on a slipping phone, or when you hesitate before answering a message, or when your hand hovers over two different snacks in the kitchen late at night. These are ordinary moments, fleeting, familiar, often forgotten, but they carry a quiet weight. They remind us that choices, even simple ones, have direction. They point us down one path instead of another. In the gentle light of evening, these moments sometimes echo louder. You might think back and wonder, what would have happened if you had turned left instead of right? If you had waited 2 more seconds before stepping outside? If you had chosen the other option? These thoughts are not signs of regret. They are part of how our minds explore possibility. And tonight, we follow that thread deeper, looking at how this feeling of diverging paths mirrors something remarkable happening in the smallest building blocks of the universe. Imagine again the simple moment of dropping your phone. You feel the device slipping. In one version of the story, it lands safely in your palm, rescued at the last instant by a lucky reflex. In another version, perhaps more familiar, it slips through your fingers, meets the floor with a soft, tragic thud, and the screen spiders into a new, unwanted pattern. In your everyday experience, only one of these becomes real. But the quantum world whispers something different. It suggests that before the moment is fully resolved, both possibilities hover side by side like transparent sketches, waiting for the universe to settle into one. To bring this closer, imagine holding a coin above a table. Before it lands, it spins in a blur, and during that blur, the coin isn't committed to heads or tails. In truth, the coin is always classical. It'll land one way or the other. But a quantum particle, when placed in a similar situation, behaves differently. Before it's measured, it does not hover between two outcomes the way a spinning coin does. Instead, it genuinely occupies a blend of possibilities, a soft superposition of outcomes that only separate when something touches the particle, when the universe demands an answer. This feels abstract at first, but it is actually what gives the quantum world so much character. Before being disturbed, a particle exists in a cloud of maybe. This cloud is not a metaphor. It is how the world behaves when no one forces it into a definite state. Imagine fog pressing against the window of a quiet cabin, its edges shifting, never clearly defined, containing shapes that could be branches or shadows, or nothing at all. That is the nature of quantum possibility. Now bring this back to your everyday experience. Think of once again holding that cup of morning coffee, warm, aromatic, promising. Before you taste it, there's a tiny moment when it exists in two emotional states. It might be exactly what you hoped for, or it might be too bitter, too cold, a small disappointment waiting to happen. You don't know which until you lift the cup to your lips. Before that sip, the possibilities overlap lightly, like a soft chord not yet resolved in a piece of music. This is, of course, a metaphor. Your coffee isn't truly quantum, not in the scientific sense. But the feeling of multiple outcomes brushing past you is something your mind already understands. It is what allows us to grasp, emotionally, poetically, what scientists observe in the quantum world. Now imagine that the cup could behave like a quantum particle. Before you sip it, it wouldn't simply maybe taste good or maybe taste bad. It would exist in a shimmering blend of both experiences. Only when you taste it, only when you interact with it intimately, would the possibilities separate. And in a view like the many worlds interpretation, the separation wouldn't discard one outcome in favour of the other. Instead, each possibility would continue quietly in its own branch of reality. In one branch, you enjoy the sip. In another, you wince slightly. In each branch, you continue on, unaware that the other taste still lingers elsewhere. This is not meant to be literal for your cup of coffee, but it helps us imagine how the smallest particles behave when they face two paths. They do not choose, they explore both. They follow one trail and simultaneously drift along another, at least until something presses them into a single story. And even then, according to the many worlds view, the other stories remain, simply hidden from your experience. The idea becomes even stranger when we consider quantum tunneling. Think of it as a particle reaching a barrier, a wall too high for it to climb. In the classical world, the particle would bounce back, defeated by the obstacle. But in the quantum world, possibility is more fluid. The particle may appear beyond the wall, not because it forced its way through, but because its wave of possibilities extends slightly to the other side. It's as though the particle briefly borrowed a path forward that classical physics would forbid. You and I cannot walk through solid doors, but at a quantum scale, the universe leaves room for these unusual outcomes, like a secret passageway that opens only for the very small. Even the sun above you relies on this behaviour. Without quantum tunnelling, the particles in the sun would not have enough energy to fuse and release the light that reaches the Earth. Every sunrise, every warm afternoon, every patch of sunlight on the floor comes from quantum possibilities slipping through barriers that should have held them back. Our world is, in a sense, powered by improbability, by nature allowing the unlikely to become real. We can even revisit the idea of entanglement here, the quiet bond that two particles can share even when far apart. When two particles become linked, their possibilities intertwine. Whatever happens to one affects the other instantly, not through any signal or message, but because they share a single, delicate story. It is as if two dancers begin a routine and continue to mirror each other, even after being pulled onto opposite sides of a wide stage. This connection too helps us understand the way the universe might branch and separate, with different outcomes unfolding in different directions. As you listen, you may begin to sense that the universe is not a rigid machine, but something softer, like a fabric that gives slightly under pressure. Events do not snap into place immediately. They shimmer through a haze of possibilities before settling into the story you experience. This shimmering is not fiction. It is the quiet rule of the quantum world, the rule that governs particles too small to see yet too important to ignore. And so, as we continue gently into the night, keep this in mind. The forks in the road you feel in your own life, the moments when two futures seem equally plausible, are faint echoes of the constant branching happening in the universe's smaller scales. Your intuition is not wrong. The sense that life could unfold in many directions is woven into the universe itself. And in the quantum world, it is not just a thought, it is a way of being. When you're ready to drift onward, just let me know, and we'll continue exploring how these shimmering possibilities shape the world you move through. As you settle more deeply into the quiet of this evening, we begin to walk through some of the most curious tools of the quantum world, tools so small and so delicate that they never disturb your daily life directly. yet shape every breath you take and every patch of sunlight that touches your skin. These are not tools made of metal or gears. They are not machines that hum or engines that burn. They are the rules and quirks built into reality itself, tucked beneath everything familiar. And though physicists describe them with symbols and equations, tonight we leave all of those behind. Instead, we explore them gently, like secrets whispered through the fabric of existence. Let us begin with quantum tunneling, a phenomenon that feels almost like a story from folklore. Imagine a small particle approaching a solid barrier. In the world you know, when something hits a wall it stops, a thrown ball bounces back, a bird veers away, a wave rises and falls but does not push through stone. That is the world of classical certainty. But the quantum world is more permissive, more flexible, almost dreamlike. When a quantum particle approaches a barrier, it does not have the energy to climb over. It does something astonishing. Part of its soft cloud of possibility gently slips to the other side. Not with force, not by breaking anything, but by allowing the universe's own rules to bend slightly around it. If this seems difficult to imagine, consider a faint echo passing through a closed door. The door is solid, yet sound manages to find small pathways, tiny cracks in the structure that let a ghost of the voice pass through. A quantum particle behaves in a similar way, except the particle does not need cracks or holes. It uses its own uncertain nature, the way it hovers in possibilities, to seep through. In the language of physicists, this is called tunneling, but we can think of it more gently as a quiet crossing, a soft permission granted by the universe. This soft crossing is not a small detail. Without it, the stars would not burn. Deep inside the sun, enormous pressure tries to push particles together so they can fuse and release energy. But even that pressure is not enough, by classical standards, to overcome the barrier that keeps these particles apart. The sun shines only because quantum tunneling allows particles to slip ever so slightly into places they are not supposed to reach. It is a kind of cosmic generosity, a subtle bending of the rules that sustains all life on Earth. When you feel the morning sun on your face, or notice the warm edge of a sunset, you're feeling the result of quantum tunneling from millions of miles away. The light that nourishes plants, warms oceans, and drives weather patterns is born from the quiet willingness of particles to explore the improbable. It is humbling to realize that improbability keeps our world alive. Now let us move to another phenomenon, entanglement. This one has a softer, more mysterious tone, like two dancers whose steps remain perfectly linked even when separated across a vast ballroom. Entanglement arises when two particles interact in such a way that their futures become intertwined. After that, no matter how far apart they drift, something in their behaviour remains connected. What happens to one influences the other, not because of a signal travelling between them, but because they share a single, delicate story that neither can escape. It is tempting to imagine threads stretching across space, tying particles together like beads on a string. But entanglement is stranger than that. The particles are not connected by cords or invisible wires. Instead, their deep relationship comes from the way their possibilities are woven together. When one particle chooses a particular path or state, the other completes the pattern instantly, as though filling in the final stroke of a painting. This happens even if they're too far apart for any message to travel between them in time. Their coordination does not break the universe's speed limit. Rather, it bypasses the need for communication entirely. The two particles are simply parts of the same quiet story. If this sounds uncanny, that is because it truly is. Even Einstein, careful, thoughtful and cautious Einstein, found this unsettling. He called it spooky action at a distance, a phrase that captures both the wonder and discomfort of the idea. Yet experiment after experiment has shown that the universe really does allow such connections. Entanglement is not a poetic exaggeration. It is a property of the world, as real as gravity and as fundamental as the passage of time. To bring this idea closer to human scale, imagine two lanterns floating in different rivers. Even if the rivers take them in different directions, the glow of each lantern flickers in perfect harmony with the other. They respond to the same quiet rhythm, even though no one can see or touch the thread connecting them. That thread is entanglement, not a physical cord, but a shared story of possibilities. This subtle connection plays a role in how the universe might branch into different versions. When two particles become entangled, their possibilities become linked, and when the environment interacts with them, when light bounces off them, when air molecules brush against them, those interactions ripple outward, connecting larger and larger pieces of the world. Over time, entire environments become woven into these shared possibilities. When one piece of that environment nudges a particle into a definite story, everything entangled with it nudges as well. In this way, entire branches of reality separate from one another. This is why some physicists believe that many worlds arise naturally, not because the universe splits dramatically like a crack forming in ice, but because entanglement and the gentle leaking of information cause different outcomes to become isolated from one another. Once separated, these branches cannot interfere, cannot merge, and cannot share information. They drift apart like the soft parting of fog into different layers. Let us return for a moment to the idea of waves. In quantum mechanics, particles are described not by tiny dots or small spheres, but by gentle, undulating shapes, waves of possibility. These shapes do not have rigid edges. Instead, they spread out, overlap, and influence each other. When you imagine a pool with ripples spreading across it, you're already close to understanding how quantum particles behave before measurement. The waves interfere, creating bright patterns where crests reinforce one another and dim regions where troughs cancel out. These interactions determine what we eventually observe. But once the environment gets involved, once countless tiny interactions occur, the subtle interference patterns dissolve. What remains is a single outcome for us to experience, even though the other outcomes continue elsewhere in the grand tapestry of possibilities. All of this can feel distant from daily life, and yet, every choice you make, every sound you hear, every spark of thought arises from atomic and subatomic events guided by these rules. When electrons leap in your nerves, when synapses fire gently in your brain, when atoms vibrate in the air around you, they follow the same quiet principles we're describing now. You're never far from the quantum world. You are built from it. As the night deepens and thoughts slow, it may be comforting to know that beneath everything solid and certain lies a softer, stranger foundation. It is a foundation that allows particles to slip through barriers, to remain linked across distances, to ripple through possibilities, and in that softness, physicists find clues that help them imagine a universe where many outcomes can exist side by side. When you're ready, feel free to let me know, and we can continue drifting into how these delicate behaviors begin shaping the larger story of measurement, reality, and the possibility of countless versions of you. As we continue drifting deeper into the quiet landscape of the quantum world, it becomes clearer that the behaviors we've been exploring, tunneling, entanglement, and the hazy, wave-like nature of particles are not isolated curiosities. They are building blocks, small stepping stones leading us toward a much larger question about the nature of reality itself. At first glance, quantum strangeness seems confined to the realm of the tiny, tucked away beneath the surface of ordinary life like roots hidden beneath the soil. But the more gently you lean into it, the more it feels as though these microscopic quirks are whispering something about the world we live in, the choices we make, and even the story of who we are. Consider again the behavior of a single particle, a grain of possibility drifting in a shimmering cloud of maybe. It hovers, undecided, until the universe presses a question upon it. Only then does it settle into a single outcome, while the rest of its potential paths fade out of your personal experience. Yet there is a quiet suggestion that those paths might not vanish completely, that they may continue in ways we do not witness. This idea is both scientific and poetic, bridging logic with imagination. The strange dances of particles might seem far from the human scale. After all, your daily routine is filled with solid, dependable events. A book sits where you placed it. A light switch clicks on with certainty. A cup warms your palms and does not waver between two temperatures at once. The macroscopic world feels determined, steady, unambiguous. It is the world we trust because it behaves in ways we can predict and understand. But beneath that stability lies a layer of possibility so delicate that we rarely notice it. Every object around you, every grain of dust floating in the air, every thread of your clothing, every cell in your body is made of quantum particles. These particles follow rules that do not align with our instincts. They whisper in probabilities, travel along overlapping paths, and interact with one another in ways that defy simple imagery. And yet, when they gather in huge numbers, like a choir of voices blending together, their individual strangeness dissolves into the predictable world we know. This smooth blending from microscopic uncertainty to macroscopic clarity is one of the most intriguing puzzles in physics. How does a world built from possibilities transform into a world of clear outcomes? How does a haze of superposition become a solid reality? When does the dreamlike fluidity of quantum behavior solidify into the classical world we experience every day? Physicists have proposed different answers over the decades. The traditional view, the one taught for much of the 20th century, rests on an idea called wave collapse. Although the original theory writes this collapse using symbols and equations, we can imagine it more softly. When you observe a particle, the universe chooses a definite state from among the many possibilities. The act of measurement gently presses the quantum haze into a single reality. It is like touching a rippling pool and watching the waves settle under your fingertips. Before the touch, the surface contains many overlapping motions. After the touch, it calms into one. But this explanation, while simple, leaves many questions unresolved. Why should looking at something, merely observing, carry such power? Why would the universe care that a conscious mind, or even a simple measuring device, has turned its attention to a particle? There is something strange in assigning such an important role to observation, as if reality waits to be noticed before deciding what it ought to be. This discomfort led scientists to explore deeper. They began to notice that the world around any particle, the environment itself, plays a crucial role. The environment isn't just the air or the temperature, it is the entire sea of interactions surrounding a particle at all times. Photons brushing against it, molecules passing by, vibrations in the field of space. It is a constant, gentle storm of contact. And each of these tiny interactions takes a sliver of information from the particle, pulling it into the larger world. This soft leakage of information is known as decoherence, though tonight we can think of it as the gradual fading of overlapping possibilities. Imagine you whisper a secret into a vast room filled with moving air. The whisper might start clear, but each swirl of wind blurs it, softens it, and carries different hints of it into different corners. Before long, the original sound is dispersed, impossible to retrieve fully. Decoherence works in a similar way. Once the environment has touched a particle enough times, the delicate overlap of possibilities becomes too blurred to remain coherent. The world then appears to choose one outcome, but really, the alternatives have simply drifted beyond the reach of interference. They no longer overlap. They no longer combine to produce the quantum effects we associate with superposition. They become separate notes instead of a chord. This raises a profound question. If the overlapping possibilities do not truly disappear, if they simply separate into distinct stories, then what becomes of them? Are they still real? Do they continue somewhere beyond our sight? Decoherence suggests an answer that is subtle and astonishing. It says that when the environment disperses the overlapping possibilities, each possibility evolves independently, isolated from the others. They follow their own paths, guided by the same physical rules, but no longer able to influence one another. And here, the boundary between microscopic oddities and big philosophical questions becomes almost invisible. If every possibility continues in its own way, then the universe might not be a single thread, but a woven tapestry of many. The small events you never see, how a particle slipped one way instead of another, might unfold beside your own story, never touching it, never revealing themselves, yet still part of reality's full picture. It can feel overwhelming to imagine layers of existence unfolding at once, but another way to think about it is gentle and comforting. The world is rich. It holds more stories than we experience. Many of them run quietly alongside our own, like neighbouring paths in a forest. You walk down one path, the others remain, even if you cannot step into them. This idea becomes even more powerful when we apply it to the choices we make. The moments in which two futures seem equally possible may be echoes of what happens in the quantum realm. On the surface, you choose one path, but somewhere in the deeper structure of reality, perhaps both paths exist, each one growing into its own quiet branch. We feel the weight of choice not only because choices shape our lives, but because the universe itself seems to hold space for many possibilities at once. The microscopic and the macroscopic are not separate worlds. They are two layers of the same existence. The tiny, shimmering probabilities you never see are the foundation of the solid, dependable world you navigate every day. And hidden in these foundations is a hint that reality may be far wider than the story we experience. Wide enough to hold many versions of events, many outcomes, perhaps even many versions of you. When you're ready to move forward, just let me know, and we'll continue into the gentle mystery of how looking at something, simply observing, might shape the world you live in. There is a quiet, almost meditative moment that happens whenever you observe something closely. Imagine staring at a candle flame in a dark room. At first, you simply see a soft glow, but as your eyes adjust, you begin to notice details you never saw, the colours shifting from pale blue at the base to warm gold at the tip, the faint sway of the flame responding to currents you cannot feel, the slight crackle of melting wax. The flame wasn't any less real before you looked. You were simply unaware of the layers hidden within it. Observation didn't create the flame, but it changed your relationship with it. In the quantum world, observation carries an even deeper significance. It doesn't just change your understanding of what you see, it changes what happens. This idea sits at the centre of what physicists call the measurement problem, though we can keep that phrase soft and simple tonight. At its core, the problem asks a gentle but unsettling question. Does watching something influence the way it behaves? To appreciate the strangeness of this, imagine again the double-slit experiment, not with technical details or symbols, but as a small story. Picture a tiny particle, something unimaginably small, yet endlessly surprising. drifting toward two narrow openings carved into a barrier. If you do not observe the particle, if you simply let it move freely, it spreads out like a wave and travels through both slits at once. It truly does. Its wave of possibility fans out, passes through both openings, and forms a pattern behind them that shows it behaved like something with multiple paths. But now imagine placing a small device that quietly watches which slit the particle chooses. The moment you do this, even if the device is gentle and does not disturb the particle in any mechanical way, the magic dissolves. The particle no longer acts like a wave. It behaves like a tiny classical object and travels through one slit only. The ripple pattern disappears. The world becomes crisp again, as if the particle has chosen a single path because you, or your device, insisted on knowing which one. This isn't just odd, it is profoundly mysterious. Why should the universe care whether we are watching? Why does the act of measurement, even by a machine with no consciousness, cause a particle's many possibilities to collapse into a single one? And if the particle truly had been travelling through both slits at once, what happened to the other path when we decided to look? For a long time, physicists avoided these questions by claiming that reality only takes on definite properties when measured. They would say that before you look, a particle doesn't have a true position, or speed, or even a well-defined path. It only gains these attributes when something interacts with it. This explanation works mathematically, but it leaves many people uneasy. It suggests that reality depends on us, that the universe waits for our attention before committing to a single truth. Einstein, in particular, found this deeply unsatisfying. He once asked, with gentle humour, whether the moon would still be there if no one looked at it. The idea that observation makes reality seemed too magical, too centred on human experience. He believed the universe should exist fully and objectively, whether or not anyone is paying attention. And this discomfort led many scientists to search for deeper explanations. One such explanation comes from what we began exploring earlier, decoherence. Instead of placing a mystical spotlight on the observer, decoherence tells us that it is not observation itself that changes reality, but interaction. When a particle moves through the world, it is constantly brushed by the environment, by stray photons, by vibrations, by a sea of invisible interactions. Each contact takes a bit of information from the particle, gradually blurring and separating its overlapping possibilities. What we call observation is simply one more interaction in a universe full of them. In this view, measurement does not collapse anything. It just nudges a particle into a larger environment where its many possibilities can no longer overlap. They become isolated, drifting into their own stories. And while we experience only one of those stories, decoherence suggests that the others might continue unfolding on their own, like branches growing from a single trunk. To understand this more intuitively, imagine a soft chord played on a piano. When the notes are pressed together, you hear a single rich sound. But if you place your hand on the strings inside the piano, muting them just slightly, the chord loses its coherence. The combined sound fades, leaving only the individual notes faintly vibrating on their own. Decoherence works similarly. It doesn't destroy possibilities, it separates them. But even this raises questions. If multiple possibilities continue, why do we only ever experience one? Why does our story flow down a single stream while others drift out of reach? To explore this, imagine standing at a gently flowing river where two smaller streams meet. In one stream, leaves drift left. In the other, leaves drift right. They diverge peacefully, each carrying its own cargo of motion and momentum. If you follow one stream, you will never meet the leaves carried by the other, no matter how much time passes. Both streams exist, both continue, but your path aligns with only one. This is how decoherence paints the structure of reality. The different outcomes of a quantum event are like streams flowing away from one another. They cannot merge back or exchange information. Once separated, they become independent, and you, like a leaf drifting along, experience only the stream you happen to be in. Now comes the subtle beauty of the many worlds interpretation. Instead of saying that the universe chooses one stream and discards the rest, many worlds suggest that all streams continue. Each possibility grows into its own quiet world, unobserved by the others. There is no collapse. There is only expansion, gentle, branching expansion. When you observe a particle taking one path, you're simply following the branch in which that outcome occurred. A different version of you, equally real but forever inaccessible, follows the branch where the other path was taken. You do not feel yourself splitting. You do not notice anything strange. Your memories remain seamless. You wake, breathe, think, and move forward without any sense of branching. Yet, the structure of reality may be far richer than what you experience. This brings us back to the measurement problem. What we traditionally think of as collapse might not be a collapse at all, but a shift in perspective, a narrowing of experience to one branch of a vast unfolding whole. The act of looking changes the story not because we force the universe to decide, but because we align ourselves with one of its many possible narratives. The candle flame still burns with or without your attention. But in the quantum world, the flicker of possibility beneath that flame may split into countless flickers, countless shadows, countless worlds, all drifting quietly beneath your experience. Whenever you're ready, let me know, and we can continue drifting into how these branches might separate, grow, and form the many worlds some physicists believe are unfolding all around us. As we drift further into this quiet exploration, it becomes clear that the line between the quantum world and the world you live in is not as sharp as it first appears. The microscopic realm might seem distant, tucked away behind layers of everyday solidity, yet it influences everything, from the warmth in your hands to the rhythm of your heartbeat. And within that realm lies a process so subtle, so understated, that you never feel it happening, even though it shapes every moment of your life. This process is known as decoherence, but tonight we will understand it not as a technical concept, but as a gentle fading of possibilities, a soft blending that allows the world to appear steady and familiar. To begin, imagine standing in a room filled with fog. The air is thick and soft, and the shapes around you dissolve into vague outlines. Now imagine someone slowly opening a window. A breeze moves through the room, stirring the fog, thinning it in places, scattering it in others. Before long, the fog no longer forms a single unified cloud. Instead, it becomes a series of faint wisps drifting in different directions. The fog has not vanished. It has merely faded into separate strands that no longer overlap. This is the essence of decoherence. At the smaller scales, particles do not have definite positions or paths. They exist in overlapping possibilities, in a fog of maybes. But the world around them, the environment, constantly interacts with them. A passing photon brushes a particle like a breeze brushing fog, disrupting its delicate overlap. A nearby vibration adds a new ripple. Each interaction scatters a piece of information, making it harder for the particles' many possibilities to coexist. Eventually, the overlapping possibilities separate so much that they no longer interfere with each other. The fog has become so thin that each wisp drifts independently. That is the moment when the world appears to choose a single outcome. But from the perspective of the quantum world, nothing has been chosen. Nothing has snapped into place. The possibilities have simply drifted apart, each one continuing on its own quiet path, isolated from the others. This idea helps us understand why we do not see quantum superpositions in our everyday lives. You never find yourself in a blur of positions, half in one place and half in another. You never see a chair shimmering between two arrangements or a cat existing in two states at once. It is not because these mixed states are impossible, but because they decohere incredibly quickly, so quickly that you never glimpse the crossover. The environment around you is constantly opening the window, scattering the quantum fog before it can take shape in your experience. To make this even gentler, imagine a violin string vibrating after it has been plucked. In the beginning, the sound is pure, rich, and full of tone. But as the vibration travels through the instrument's body, into the air, into the walls, and into the world, the sound spreads out. It becomes duller, thinner, and eventually fades into silence. The vibration hasn't stopped suddenly. It has simply shared itself with everything around it until none of it remains concentrated enough for you to hear. Decoherence works in a similar way. The pure quantum possibilities become entangled with their surroundings, sharing information until they disperse into separate, quieter outcomes. This entanglement is a delicate word, but we can soften it too. Think of entanglement as two dancers whose steps depend on each other. When the environment interacts with a particle, it becomes one of those dancers, moving in response, taking part in the choreography. Each touch with the environment adds another dancer to the floor, until the original duet becomes an intricate pattern involving countless partners. Eventually, the original steps are impossible to recognize. The dance continues, but the original movement has dissolved into the crowd. Decoherence is the universe's way of smoothing the rough edges of possibility. It transforms shimmering maybes into the solid impressions that fill your senses. It turns quantum clouds into classical shadows, uncertainty into familiarity. Without it, the world would be a ghostly blend of overlapping outcomes, never fully resolved. Instead, you wake each morning to a world where objects have clear shapes, where events unfold in a single line, and where your memories form a coherent story. Yet the implications are profound. If decoherence simply pushes different outcomes into separate, non-interacting strands, then what we think of as the outcome may only be the one we happen to experience. The others continue, drifting alongside ours but forever beyond reach. It is like listening to a single instrument in a vast orchestra and forgetting that the other instruments are still playing, each following its own melody, each contributing to a whole far larger than you can hear. This raises gentle questions about the nature of reality. If the universe does not erase possibilities but separates them, then what becomes of the possibilities you do not live? Are they still part of reality? Do they form their own branches of the world? And if so, what does that say about the story you walk through each day? Decoherence does not answer these questions fully, but it opens the door to interpretations that are both scientifically grounded and emotionally resonant. One such interpretation is the many worlds view, the idea that each possible outcome becomes its own quiet version of reality when decoherence isolates it. These versions do not split with a loud crack or flash of light. Instead, they separate gently, like threads drifting apart in a current, each thread carrying a complete and stable world with it. You might imagine, for instance, that a single quantum event, such as a particle taking one path instead of another, begins a new branch of existence. In one branch, the particle behaves one way. In another branch, it behaves differently. Decoherence ensures the branches do not mix or interfere, and as larger systems become entangled with these particles, atoms, molecules, biological tissues, eventually entire bodies and environments, these branches expand into full versions of reality, each coherent in its own right. This means that the familiar world you see each day is one branch of many. It is not the only story, but it is the story you experience. The other stories remain invisible, not because they are less real, but because decoherence has carried them beyond the horizon of your perception. They move forward in their own lanes, untouched by yours. These ideas may feel vast, but they also carry a comforting stillness. They suggest that the universe holds more than one truth at a time, that reality is rich enough to embrace every possibility, and that your life unfolds along a thread woven from countless moments of decoherence, moments that quietly guide you from hazy quantum origins into the crisp clarity of experience. As we continue, we will step gently from this foundation into the world of many worlds, seeing how these faded possibilities might form entire universes, each one shaped by choices, chance, and the quiet branching of reality itself. When you're ready, just let me know, and we will drift onward into that unfolding story. There are moments in science when an idea arrives so quietly that almost no one notices it. Yet that idea carries enough weight to bend the course of our understanding. Hugh Everett was a young graduate student, soft-spoken, reflective, and possessed of a mind that tended to wander into the deeper corners of questions most people considered settled. The year was the late 1950s, a time when quantum mechanics had already established itself as a powerful tool for describing the strange behaviour of particles. Yet, for all its triumphs, it carried a tension at its core, like a knot no one could quite loosen. Most physicists believed that quantum systems evolved smoothly and predictably until someone measured them. At that moment, the world seemed to snap into a single outcome. Before the measurement, a particle could be in many states at once. Afterward, only one remained. This sudden change, the so-called collapse, was accepted as part of the theory. But it always felt a little incomplete, like a paragraph missing its final sentence, or a photograph blurred at the edges. Why should the universe behave one way when unseen, and another way when observed? Why should an act as simple as looking cause the laws of nature to change their Everett approached this contradiction with an unusual kind of calm. Instead of trying to patch the existing picture, he turned the question inside out. He wondered, what if nothing ever collapses? What if the universe follows a single, smooth rule at all times, never breaking stride, never fragmenting between before and after, regardless of who is watching? To Everett, the most elegant explanation was also the boldest. The wave-like description of a system, the soft swell of possibility that physicists use to describe particles, is not a convenient mathematical trick. It is real, fully real. It describes not just what might happen, but what does happen, and it does not collapse, ever. Instead, it continues evolving like a grand, unbroken river of possibility, splitting gracefully when it meets a rock, flowing into multiple channels that preserve every outcome allowed by the laws of nature. Imagine standing before a wide delta where a river meets the sea. From a distance, it might look like a single flow, but as you approach, you see it dividing into many channels. Each channel has its own direction, its own current, its own quiet story. Yet all the channels remain part of the same river. Everett suggested that the universe behaves in much the same way. When a quantum event occurs, say, a particle deciding between two paths, the universe does not choose. It flows into both outcomes. One branch carries the version where the particle goes left. Another branch carries the version where it goes right. These branches are not abstractions or illusions. They are as real as the world you move through now. You perceive only one because decoherence, that constant and gentle blending with the environment, keeps branches from interfering with one another. They drift apart silently and peacefully. The brilliance of Everett's idea lies in its simplicity. Instead of needing a special rule for measurement, something that behaves differently from all other physical processes, he removed the distinction entirely. There is no special observer, no privileged moment where reality must decide what it wants to be. Everything unfolds according to the same smooth universal rule. Instead of collapsing, the world branches. Instead of choosing, it expands. This is known today as the many worlds interpretation, though Everett himself simply considered it the natural implication of believing that the wave description of reality, the one expressed in mathematical form, represents the world wholeheartedly. The wave of possibility does not vanish. It unfurls. It does not give up one outcome to keep another. It embraces both. No collapse means no loss of information, no abrupt shift in the laws of nature, no sudden rupture between quantum and classical descriptions. To see the beauty in this, imagine a piece of music played on a piano. You can follow one melody, a single line of notes that carries you through. But beneath what you hear, countless harmonies, rhythms, and overtones blend to create the full sound. If you were to isolate each track, you would hear dozens of intertwined stories, each contributing to the final texture. Everett's view suggests that reality is like this, a symphony of many overlapping strands, each one evolving on its own, each one real. Of course, this idea was radical. In Everett's time, most physicists were comfortable with the notion that some part of quantum mechanics was simply mysterious, that collapse was a rule we had to accept even if it did not fit neatly with the rest of the theory. Everett was asking them to reconsider the entire framework, to step back and see that the mystery might vanish if they were willing to widen their perspective. To many, this felt like too large a leap. His dissertation received little enthusiasm. Some colleagues dismissed the idea as unnecessary, while others misunderstood it entirely. Yet Everett's idea endured. Like a seed carried gently on the wind, it found fertile ground decades later, when physicists began to revisit the foundations of quantum mechanics with fresh eyes. The concept that every possible outcome unfolds in its own branch began to resonate with researchers interested in the simplicity of physical laws. If the universe follows a smooth evolution at all scales, without exceptions, then Everett's interpretation is one of the most straightforward ways to understand quantum behavior. It is worth noting that Everett never claimed to witness branching, or to experience any kind of split. In his view, you never feel yourself dividing because each version of you continues with a complete memory of the moments leading up to the branching. Each version feels whole, continuous, and uniquely themselves. From the inside, there is no rupture. There is simply life unfolding, choice by choice, measurement by measurement, branch by branch. As you listen now, you remain part of a single, coherent thread of experience. Yet Everett's idea invites us to imagine that countless other threads flow quietly beside this one, each carrying its own version of events, each shaped by small differences that ripple outward. It's not a frightening thought, nor a lonely one. Instead, it suggests that the universe is unimaginably rich, vast enough to contain every story that nature allows. When you're ready, we'll continue into the gentle unfolding of how these branches take shape, how they remain invisible to one another, and how they might create a universe that is, in truth, much larger than any of us can see. If you sit quietly for a moment and think back through your day, you'll notice a trail of choices behind you. Some small, some slightly larger, each one nudging your life in a particular direction. Perhaps you took a different route to work than usual. Perhaps you decided to let the phone ring. Perhaps you added an extra spoonful of sugar to your drink, or paused before replying to a message, or chose silence instead of speaking. These tiny decisions feel like steps along a single path, the one that leads you right here, to this moment, listening in the soft glow of your evening. But Everett's idea suggests something far stranger, and also more delicate. Every time you make a choice, every time nature makes a choice, reality might not be selecting a single road for you. Instead, it could be gently unfolding both roads, placing each along its own branch of the universe's story. You experience one branch because decoherence ensures that branch becomes your world, but many other branches flow quietly beside it, unreachable yet fully formed. To imagine this branching, let's step away from equations and instead picture something more familiar. Imagine a tree in early spring. Its branches are bare but full of subtle promise. As the days grow warmer, tiny buds appear, not all at once but gradually, each one responding to sunlight in its own time. Soon those buds open into new twigs, and the tree expands outward in quiet, organic ways. The growth isn't sudden or violent. It happens gently, invisibly, yet persistently. Everett's branching universe behaves just like that tree. At every moment, new twigs appear, not made of wood and leaf, but of possibility. This branching does not require a dramatic event. It does not wait for a grand decision. Even the tiniest quantum difference, whether an atom vibrates slightly to the left or slightly to the right, can create new twigs. That is why, in many worlds, branching is constant. It happens quietly, every moment, everywhere. Consider something as simple as rolling a die. In your experience, the die lands on a single number, perhaps a 3. But from Everett's perspective, this is only the number you witnessed in your branch of reality. The universe did not discard the other 5 possibilities. It allowed all 6 outcomes, each one forming its own branch, each one carried forward with equal grace. Or imagine tossing a coin. You watch it spin upward, catch the light in a flicker of silver, and land as either heads or tails. In the everyday world, only one answer exists, but in the branching universe, both outcomes unfold. In one branch, the coin becomes heads. In another, it becomes tails. In one, you smile at your lucky guess. In another, you don't. Both versions of you continue forward, unaware of one another, each experiencing a seamless story. And choices aren't the only triggers. Consider something gentle, like a dinner decision. If you stand in front of your refrigerator and debate between pizza or pasta, you might think of the choice as trivial, yet perhaps, deep beneath that moment, countless tiny quantum events occur in the neurons that guide your decisions. Those events, too small to feel, may nudge your thoughts in one direction or another. In many worlds, each micro-decision, each whisper of neural activity can form its own branch. In one universe, you sit down to warm slices of pizza. In another, you twirl pasta on your fork. Both meals are eaten. Both evenings unfold. Both versions of you continue with no awareness of the other's existence. This is the essence of the branching universe. Not a dramatic slicing of reality, but a soft and continuous flowering of paths. The universe does not choose one possibility at the expense of the others. It does not play favourites. Instead, it embraces all possibilities, each one nurtured into its own quiet world through the gentle push of decoherence. It's important, though, to clarify something that is often misunderstood. Many worlds is not the same as the cosmological multiverse. The word multiverse is used in many contexts, some scientific, some speculative, and it can easily become tangled. The cosmological multiverse refers to regions of space that may have different physical laws, born from vast expansions of space-time. These universes might be separated by unimaginable distances or by differences in fundamental constants. Many worlds, on the other hand, does not rely on cosmic inflation or faraway regions. It arises from a property baked into quantum mechanics itself, The idea that the universe does not collapse possibilities but allows them all. If it helps, imagine the difference like this. The cosmological multiverse is a field of galaxies, each one a separate bubble floating through an immense space. But the many worlds universe is more like a single tree, with countless branches growing out from one trunk, each branch its own timeline, its own continuation, yet all belonging to the same living structure. You cannot move from branch to branch. You cannot cut one branch to feel another tremble. The separation is complete, preserved by decoherence, which ensures the branches no longer interact once they diverge. This separation is subtle but crucial. Decoherence does not require a conscious observer or a scientific instrument. It occurs naturally. Whenever a system, whether a particle or a person, interacts with its environment, its delicate cloud of possibilities becomes entangled with the world around it. That entanglement spreads like ripples through a pond. Soon, the different outcomes become isolated from one another, each carried away like leaves drifting down separate streams. Imagine two ripples beginning close together on the surface of a pond. At first, they overlap, creating patterns, combining and interfering with one another. But as they move outward, the ripples drift apart. Eventually, they no longer touch. Two separate patterns, two separate stories. The surface of the pond has not changed its nature. It simply carries each ripple where it needs to go. That is how branching works in many worlds. The universe remains one grand structure, but its stories diverge. One branch contains the version of events that you experience. The others contain versions you will never encounter. These branches do not compete or conflict. They simply flow onward, each with its own future, and you, as a traveller along this quiet thread, continue forward unaware of the infinite versions of events you did not follow, not because they are unreal, but because decoherence places them beyond the reach of your senses. You live your life in one branch, with one set of memories, one chain of moments. Yet the full picture of reality may be far wider, a garden of forking paths, each stem carrying its own blossoms. As we move deeper into this exploration, we will look at how these branches shape the story of your life, how identity, choice, and the quiet unfolding of memory fit into a world where every outcome might continue somewhere. When you're ready, we can step into that reflection gently. If you pause for a moment and look back across the landscape of your life, not just the large events, but the small ones too, you'll see a winding path marked by choices, accidents, coincidences, and moments so subtle that you barely noticed them. A missed bus that led to meeting a friend, a small hesitation that changed the course of a conversation, a sudden inspiration that arrived for no clear reason. These threads form the story you know, the one that feels continuous, intimate, and deeply yours. But in the many worlds picture, this story is only one among countless others, each shaped by the branching moments we explored earlier. And now we drift gently into one of the most profound and quietly emotional ideas, that you may exist across these branches, each version walking a path that feels just as real, just as meaningful, and just as complete as the one you're living now. To understand this without symbols or technical phrases, let's picture your life as a long piece of woven fabric. Each day adds another thread. Each choice shifts the direction slightly. From a distance, the fabric looks like a single smooth tapestry. But look closely, very closely, and you might notice the faint suggestion of other threads nearby, threads that follow the same general pattern, but diverge in small and subtle ways. Perhaps in one strand you turned left instead of right. In another, you picked up a book you ignored here. In another, you said what you were thinking instead of holding it back. The threads are parallel, close enough to resemble one another, yet separate enough to carry different details. This is how physicists imagine the branching structure of the universe, as a web of stories, each one valid and entire. But here's the gentle, grounding part. Your experience always feels like a single thread, because decoherence ensures that the other threads drift out of reach, carried away by interactions too subtle to feel. To explore this more personally, imagine a moment in your life when you faced a decision. It doesn't have to be dramatic. It could be something as simple as whether to pause a little longer at the crosswalk. In one version of that moment, you stepped forward immediately. In another, you hesitated. Both paths may exist in the deeper structure of reality, each one forming a continuation of your story. Yet you only remember one. You can only live one. The version of you who stepped forward and the version who hesitated are both valid, both conscious, both complete, but separated so fully by decoherence that neither one can sense the other's existence. This brings us to a delicate but important idea. Who were you before that moment? Before the branching event occurred, there was only one version of you carrying the memories of everything leading up to that point. Your past is shared across all branches before they diverge. Your memories, your identity, your sense of self were one and the same. But the moment a branch forms, new versions of you begin to unfold, each containing the same memories up to the dividing moment, each believing themselves to be the original. This does not violate anything about your personal experience. In fact, it reinforces it. Every version of you feels continuous because the branching does not fracture your sense of identity. It copies it forward. It hands each version a full book of memories, a full sense of self, and says, "Continue from here." And each version does, unaware of the others who also move forward with the same story. To bring this closer to heart, imagine your life as a long hallway with many doors. You walk down the centre, touching the walls, feeling the texture of the light. Every so often, you reach a point where the hallway splits quietly into two. You choose one path, not noticing the other. But in the many worlds view, both hallways continue, and in each hallway, a version of you walks forward, lights dimming gently behind them, never sensing the presence of their counterpart. Each hallway feels like the only one. Each story feels like the original, and each you feels like you. This leads to a subtle emotional truth. If every possible version of you carries its own story, then each story still matters deeply. Your life in this branch, your joys, your struggles, your choices, remains singular to you. The existence of other branches does not diminish what you feel. It does not dilute your experiences or scatter your meaning across infinite worlds. Instead, it highlights the richness of existence itself. The you sitting here, listening in this quiet moment, is no less real, no less important, and no less unique because other versions might exist. You are the one walking this thread. You are the one living this tapestry. And what of the versions of you in other branches? They walk their own hallways, carrying their own memories, feeling their own emotions, believing themselves to be you as they are. Many worlds suggest that reality may be vast enough to hold all of these countless selves, each with its own weight and presence. Yet none of these selves interfere with one another because decoherence keeps the hallways sealed. You cannot slip from one branch into another. You cannot trade places or peer through the walls. Each story is self-contained, not because it is alone in structure, but because it is isolated in experience. There is a calmness in this idea. It means that your path is yours entirely, even if it is one of many. Your memories remain solely yours. Your feelings shape your branch in ways no other branch can mirror. You're not diluted by multiplicity. You are defined by continuity. Every version of you inherits the same past, but each creates its own future. And the version of you in this moment, the one experiencing this quiet evening, listening to these gentle explorations, has chosen, consciously or unconsciously, to arrive exactly here. In all the possible worlds, in all the branching stories, this particular version of you is awake in this particular branch. And if the universe truly does weave many stories at once, then the story you're living now is one of them. Precious, singular, unfolding with every breath. When you're ready, we can drift deeper into what it means to be you in a universe of many paths, exploring how identity and meaning hold steady even when reality may be far larger than it seems. There is something deeply comforting about believing that you are one continuous self, moving through one continuous world. You wake up in the morning, feel the familiar weight of your body, recognize the shape of your room, and recall the chain of memories that led you to today. This seamless experience, this feeling of being you, is one of the most intimate aspects of existence. It feels indivisible, singular, whole. Even on days when life feels complicated or uncertain, your sense of self remains steady, like a quiet melody running beneath all the noise. But what happens to that unity in a universe that branches? If there are many versions of you drifting along different threads of reality, each carrying its own memories and choices, then what exactly does you mean? Is your identity diluted, scattered? Or does it become something deeper and more intricate than this simple picture we're used to? To explore this gently, imagine your life as a long, continuous line of footprints in soft sand. Each step carries the impression of your weight, your stride, your direction. When you look back, you see a single trail. If you kept walking through an endless desert, your footsteps would continue forward, unbroken. This is how your identity feels: one trail, one path. But in the many worlds picture, reality does not always offer just one route. At certain moments, the path may quietly split. Two sets of footprints appear instead of one. One trail continues slightly to the left, the other slightly to the right. Each trail becomes its own version of your journey. Now imagine that each trail is just as real, just as textured, just as filled with experience as the one you remember walking. Yet you only ever feel one set of footprints as your own because the act of branching happens quietly, without fanfare, without any sense of division. Before the branching point, all versions of you are identical. They share the same childhood, the same memories, the same loves and fears and dreams. At the moment of branching, the past remains unchanged for all of them. The continuity of identity is preserved perfectly up to that point. This idea softens a common worry, that branching somehow shatters your sense of who you are. In truth, branching does not tear your identity apart, it replicates it. Each version carries the full weight of your past, not a fragmented piece of it. Each version walks forward with a complete understanding of their life so far. And each version feels like the original, because from their perspective, they are. To bring this closer to heart, imagine you're reading a book. As you turn each page, the story moves along smoothly. But what if, in another version of the book, the author inserted a small variation? A sentence changed, a character took a different action, a plot thread went in an unexpected direction. You could place these books side by side and see that they share identical chapters up to a certain point, and only afterward diverge. Each book still feels complete because the story flows seamlessly within its own pages. The same is true of you. Each version carries a story that begins the same way but unfolds differently as the universe branches. This brings us to a gentle philosophical question. If there are many versions of you, why do you experience only one? Why do you wake up in one branch, not another? A soft way to understand this is through the idea of self-locating uncertainty. Before a branching event, all versions of you in the making are identical. They share the same memories and the same perspective. They are the same person. But after the branching, each version inherits a different future. Before observing which future unfolds, you don't know which version you will become. It is like standing at the threshold of a hallway with two identical doors. You know you will walk through one of them, but until you step forward, both possibilities feel open. Only after passing through one door do you realize which space you now inhabit. This uncertainty, gentle and intuitive, is not about confusion or loss. It simply reflects the idea that, at the branching point, there is more than one continuation of your story, each carried forward by a version of you who feels entirely complete. Now consider another aspect of identity: emotion. The small stirrings of feeling that guide your decisions, the subtle weight of your memories, the quiet voice that tells you who you are. These do not fragment during branching. Each version of you carries forward the same emotional landscape. If you feel grateful tonight, then every version of you branching from this moment carries that gratitude into their next steps. If you feel tired, or hopeful, or curious, those feelings remain part of every branch that emerges from this moment. The branching does not diminish the authenticity of your emotions. It multiplies the context in which they are expressed. There is also a gentle truth about uniqueness. Even if many versions of you exist, the version you are experiencing now is unique because you are the one living it. You cannot feel the emotions of the others. You cannot borrow their memories or trade places with them. They exist beyond your horizon, just as other people's inner worlds exist beyond your direct experience. That doesn't make your world smaller. It makes it personal. Your branch becomes your home, your vantage point, your story. And if you consider the perspective of each version, each one believes they're the only you who travelled this path. Each one looks back on their memories and sees the same childhood, the same choices, the same moments of joy and sorrow. Each one feels centered in their own narrative, and each one is correct. Identity is not diminished by being multiplied. It is affirmed by continuity. Think of a candle flame reflected in many mirrors. Each reflection looks identical. Each seems to belong solely to the viewer, but the original flame still burns, giving rise to every reflection at once. The self you feel is like that flame, singular in experience yet capable of being represented faithfully wherever reality allows. In the gentle light of this idea, the many worlds interpretation becomes less of a puzzle and more of an affirmation. Your story matters, not because it is the only one, but because you are the one living it. The universe may hold countless versions of you, but this version, the one listening now, the one feeling this moment, is entirely your own. Whenever you're ready, we can continue delving into how choice and responsibility unfold within a universe that may be forever branching, and what it means to live meaningfully along just one of those many paths. When you look back across your life, it often feels as though the path you followed could have gone 100 different ways. A conversation could have shifted slightly. A friendship might have begun or faded. A different school, a different city, a different job. Each one could have unfolded into its own intricate story. And beneath that sense of open possibility lies a question that quietly follows many of us through life. Did I truly choose my path? Or was my path already set? In the gentle world of the many worlds interpretation, this question becomes even more nuanced. If every choice you might have made exists somewhere, if each yes and each no branches into its own version of reality, then what does it mean to choose at all? Does choice still matter if all possibilities happen? And what becomes of responsibility, purpose, or moral weight when every option might be lived out by some version of you? To explore this without heaviness, imagine sitting on a quiet hillside at dusk. Below you lies a small town with winding streets and glowing windows. From your vantage point, the town seems still, but if you look closely, you notice the movement of people living their lives, some turning left at a corner, some turning right, some slowing down to talk to a friend, some hurrying home for dinner. Each of these movements creates patterns that overlap and diverge. If you could watch long enough, you'd see a tapestry of choices unfolding. Now imagine that every path each person might take actually unfolds in parallel. In one branch, someone takes the long way home. In another, they stop to help a stranger. In another, they catch a moment of beauty that changes their mood for the entire evening. These branches don't conflict or compete. They simply coexist, like many soft variations of the same melody. You only hear one version because you're sitting in one part of the hillside, but the others play on quietly in the distance. This picture helps us approach the question of free will with gentleness rather than confusion. In the classical view of life, choice feels singular. You choose one thing and the alternatives slip away. But in the many worlds perspective, your experience of choosing remains absolutely real. You stand at a fork in the road, and your internal sense of weighing options, considering consequences, and making a decision belongs fully to you. That moment of choosing, of feeling the weight of possibilities, is preserved in your branch of reality. The existence of other branches doesn't erase that feeling or make it less authentic. Think of it like this. Imagine reading a story written in several versions. In one version, the protagonist chooses courage. In another, they choose caution. But when you read the version in your hands, that protagonist's choice still feels real and meaningful within that narrative. The other versions don't dilute the story you're experiencing. They simply exist alongside it. When you make a decision in your own life, you shape the version of yourself who moves forward in this branch. Even if other versions of you make different decisions elsewhere, they are not you in the experiential sense. They carry your past, but they do not colour your present. Only you, in this branch, face the consequences of the choices you make here. Only you feel the ripple effects of your decisions as they move through the days and years ahead. In this way, many worlds does not negate free will. If anything, it amplifies its immediacy. The choices you make in this branch become the defining features of the story you're living. They determine the details of your relationships, your achievements, your struggles, your moments of growth. Your decisions carve the path beneath your feet. Whether other paths exist elsewhere doesn't change the one you walk upon. It simply means that reality, as a whole, is generous enough to hold every story without forcing one to vanish. Responsibility follows naturally from this perspective. Imagine again the branching hallways of your life. In one branch, you choose kindness. In another, you choose indifference. In yet another, you choose anger. Each branch may exist, but you experience only one. The consequences of your actions in this branch return to you like echoes in a canyon. If you comfort someone today, the warmth of that act remains in your world. If you hurt someone, the impact remains in your world as well. The existence of a version of you who did something differently elsewhere does not erase the weight of your choice here. Responsibility is not diminished by parallel branches. It is localized to the life you inhabit. Your actions matter because you live with them. You face their results, carry their meaning, and feel their emotional texture. You cannot hide behind another version of yourself who made a better choice. You cannot borrow wisdom from a version who made a worse one. You are this you, and this you walks forward with the consequences of what you do. In fact, the many worlds perspective offers a kind of soft empowerment. It suggests that even though the universe contains vast branching patterns, the you in this branch remains fully autonomous within your own thread. You do not control the other threads, just as they do not control you. You're the author of your path. You make choices, shape your days, and influence the lives around you. This brings us to a gentle truth. Meaning arises from experience, not exclusivity. A sunset remains beautiful whether one person witnesses it or 1,000 do. A kind act remains kind even if countless other versions of you are living other lives. Meaning is not made smaller by multiplicity. It is made richer by consciousness. And your consciousness, the one reading or listening in this moment, is the center of your lived experience. Even deeper still, many worlds adds a quiet comfort to the idea of regret. If you have moments you wish had gone differently, branches may exist where they did. That does not erase regret, but it softens it. It suggests that your life is not defined only by what happened, but also by the vast landscape of what could have happened, a landscape that may still be alive in distant, unreachable parts of reality. Your heart remains rooted here, but the universe holds room for all versions of you. So free will, rather than dissolving, becomes something more gentle than the traditional picture, less rigid, less pressured, more spacious. You choose because choosing defines your experience, your path, your emotions, your growth. Choice matters not because it is the only path, but because it is your path. And responsibility remains essential because no matter how many branches exist, only one holds the you, experiencing this breath, this thought, this moment. That alone gives your choices weight. When you're ready, we can drift into one of the most thought-provoking and delicate ideas connected to many worlds. The possibility that some branches might contain versions of you who survive events you do not, as we explore the soft philosophical and safe idea known as quantum immortality. There is a certain tenderness in the way we think about survival, the way we imagine ourselves moving forward through time, step by step, breath by breath. Life, when we feel it closely, is fragile but persistent, like a candle flame swaying in a quiet room. It continues despite drafts, despite shadows, despite the uncertainty that sometimes hangs in the air. This fragility is part of what makes life beautiful. It reminds us that every feeling, every moment, every connection carries a kind of luminous weight. In the many worlds interpretation, this fragility meets a peculiar idea, one that has sparked curiosity, discomfort, fascination, and debate. It is often called quantum immortality, though the phrase can be misleading if taken literally. What it truly represents is a philosophical exploration rather than a claim about real survival. Tonight, we treat it gently, as a thought experiment held at arm's length, not as a guide to action or belief. To understand the idea in its softest form, imagine that in certain rare moments, the difference between living and not living could depend on tiny, quantum-level events. The sort of outcomes that, in the many worlds picture, branch into separate versions of reality. In one branch, a particle behaves one way. In another, it behaves differently. If these outcomes cascade upward into the human world, they could in theory create branches where a person survives a close call and others where they do not. The idea of quantum immortality arises from imagining that a conscious being would always find themselves in a branch where they continue to exist, because awareness cannot follow a path where awareness has ended. In this thought experiment, you would only ever experience the branches in which you survive, no matter how improbable that survival might be. This has led some philosophers to wonder, could there exist a branch, however unlikely, in which you continue on indefinitely simply because your consciousness flows naturally toward any path that still contains you. But it's important to emphasize something immediately. This is not a claim about what truly happens. It is not a promise of eternal life or an invitation to seek danger. It is simply a conceptual exploration, a soft question about where consciousness might find itself in a universe with many possible branches. Most physicists treat it as an intriguing but speculative idea, one with no real evidence, no practical application, and many philosophical limitations. So why mention it at all? Because in the gentle landscape of many worlds, it raises deeper questions about luck, survival, and the meaning of your unique presence in this branch. It invites reflection, not action. And when treated safely, it opens a window into how delicate the boundaries of our experience might be. Think for a moment about the improbable escapes in your own life, times when events aligned just right for you to avoid harm or find safety. Perhaps you crossed the street a second earlier or later than you otherwise might have. Perhaps you caught something falling just before it broke. Perhaps a small change in timing spared you from an accident. These moments often feel like luck, like the universe nudging you gently towards safety. In the many worlds picture, such moments could be viewed through a different lens. In some branches, your timing might not have aligned. In others, it did. You find yourself in a branch where events unfolded favourably, not because of destiny or cosmic orchestration, but because that is the branch you're experiencing. In this sense, luck becomes less of a roll of the dice, and more of a quiet reminder that your life sits among countless alternatives, most of which you can never access or feel. This perspective does not turn survival into inevitability. It does not erase risk or replace caution, but it offers a gentle shift in understanding that your presence here, your continued existence in this particular thread, may be one of many possible outcomes, and the fact that you are here means that your thread continues forward. In this context, quantum immortality becomes less a statement about endless life and more a reflection on the resilience of consciousness. It reminds us that our awareness is always rooted in the version of reality where it persists. When your eyes open each morning, when you draw breath, when you lean into the feeling of being alive, you're experiencing the branch where your story continues. This is not miraculous. It is simply the nature of existence as you experience it. But there is a limit here, a gentle boundary we must respect. The many worlds interpretation is a scientific framework, not a spiritual system. It does not promise safety. It does not grant immortality. It does not protect you from harm or ensure that your story goes on forever. The idea that consciousness would always experience survival is speculative, controversial, and incomplete. Many scientists argue that even if branching occurs, there is no guarantee that subjective experience continues without interruption. Some interpretations suggest that consciousness is tied to physical structures that cannot branch infinitely. Some argue that survival in improbable branches becomes so unlikely that these branches fade into irrelevance. In simpler terms, quantum immortality is a philosophical puzzle, not a path to eternal life. At the emotional level, though, this idea can help clarify something gently profound about being alive. It reminds you that life is precious precisely because it is not guaranteed. The version of the universe you're experiencing right now, the one in which you are breathing, listening, thinking, is one among many, and its continuation is something to hold with gratitude, not assumption. The branching of reality does not diminish your fragility. It deepens your appreciation of the present. Imagine lighting a candle in a dark room. The flame flickers softly, casting shadows that dance along the walls. Many possible drafts could blow it out. Many could leave it untouched. But the candle's light is no less warm because other possibilities exist. In the same way, your life glows here, in this branch, carrying its own warmth. The presence of other branches does not dim it. It simply expands the canvas on which existence is painted. And so, in this quiet moment, quantum immortality becomes not a literal idea, but a symbolic one. It invites you to reflect on the improbable beauty of waking up each day. It invites you to consider that your survival, your growth, your continued presence is a thread worth cherishing, because it threads through a universe full of alternatives you will never see. The many worlds perspective, when held gently, does not transform life into something endless, but it does transform life into something vast, something interconnected, something full of quiet echoes and unseen pathways. And within that immensity, the version of you listening now remains as real, as valuable, and as finite as ever. Whenever you're ready, we can drift into the next chapter of our exploration. How evidence and experiments illuminate these ideas, and how scientists continue searching for the subtle hints that might reveal whether branching is truly woven into the fabric of the cosmos. When we imagine the many worlds interpretation, it can feel like a vast poetic idea, a vision of reality branching gracefully into countless pathways. But for physicists, the question is always grounded in something quieter, more concrete. What does the evidence suggest? Not evidence of other worlds directly, because the very nature of branching means those worlds drift out of reach, but evidence that the rules of quantum mechanics behave more like a branching river than a collapsing wave. So tonight, as we drift deeper into this gentle exploration, we look at the experiments that lightly touch the edges of many worlds, not proving it, but whispering in its direction. We move slowly and softly, without equations, without symbols, letting images and analogies carry us through. Let us return first to a familiar experiment, the double-slit experiment. We explored earlier how a particle behaves like a wave when unobserved, passing through both slits at once, and how its wave-like pattern disappears when we try to watch which path it takes. Many Worlds interprets this not as the universe choosing one outcome, but as the splitting of a wave of possibility into branches, one branch where the particle passed through the left slit, another where it passed through the right. When we observe, we entangle ourselves with the particle's fate, which in turn separates one branch from another through decoherence. We do not see the interference pattern when we watch, because our act of watching binds us to one branch. But this experiment, for all its elegance, is just the first whisper. To truly test the boundary between our world and the quantum one, scientists have built newer versions of the experiment using objects far larger than simple particles. Imagine a small molecule, something made of dozens, even hundreds of atoms, drifting through space. It is still minuscule, but compared to a lone electron, it is a cathedral. These molecules have been sent through double-slit setups, and astonishingly, they still behave like waves. They still show interference. They still act as though they travel through two paths at once. One experiment used molecules so large they resembled tiny chemical sculptures, yet they still carried the unmistakable signature of quantum behavior. This matters deeply to the many worlds interpretation. If quantum effects persist as we build larger and larger structures, it suggests that the boundary between quantum and classical, the point where collapse was once thought to occur, is not a fixed line. Instead, it fades softly as systems interact more with their environment. Decoherence increases, branches separate, and the world appears classical, not because of a sudden collapse, but because possibilities leak into countless faint threads that never meet again. Now imagine a dust particle, something barely visible to the naked eye. Experiments are being designed to place such objects into delicate states, where they behave like quantum waves, not because dust is mysterious, but because scientists are learning how to shield objects from environmental interactions long enough for their quantum nature to show itself. The idea that a dust mote, something you might brush off your sleeve, could enter a superposition of places at once stretches the imagination. But if those experiments succeed, they make many worlds feel less like a speculative interpretation and more like a natural extension of quantum behaviour across all scales. Another experiment that brushes against the edges of many worlds involves interference between paths that are only partially isolated. Picture a particle that can take two routes, one long and one short. When researchers manipulate the environment between these routes, the interference patterns change in ways that suggest the environment itself is sharing information with the particle, nudging different branches apart. This is decoherence in action, not as a concept, but as something we can measure and observe. The more information the environment receives through light, heat, vibration, the more quickly the branching paths diverge. If we imagine decoherence visually, it becomes almost poetic. Picture two ripples on a pond that start close together. As the wind blows across the surface, it disturbs the water, scattering the ripples until they no longer overlap. The water still holds both ripples, but their interference, the pattern that reveals they were connected, is gone. In the same way, decoherence ensures that different possible outcomes drift apart. Many worlds simply says, they keep drifting, each becoming its own world. But scientists have searched for another kind of experimental hint as well, something subtler. If collapse were truly a physical event, a literal snapping of the wave into one outcome, then under certain conditions, this collapse should leave traces. It should create noise or anomalies in measurements, tiny disruptions in the statistics. Many experiments have looked for these signals. So far, none have appeared. Every result aligns with the idea that quantum evolution is smooth and uninterrupted. This does not prove many worlds, but it weakens interpretations that rely on collapse as a real, physical mechanism. Another quiet whisper comes from quantum computing. These delicate machines rely on superposition and entanglement to perform certain computations faster than classical computers. They operate in a realm where many possibilities evolve simultaneously before decoherence forces a particular result to emerge. Some physicists describe this as the computer exploring many paths at once, and while this is metaphorical, it resonates with the many worlds viewpoint. The more powerful quantum computers become, the more they push our intuition toward the idea that nature naturally explores multiple outcomes at once. But perhaps the most striking experimental hint comes from the sheer stubbornness of quantum mechanics. No matter how many experiments scientists have performed, no matter how clever the design or how extreme the conditions, quantum theory has never broken. It continues to predict outcomes with astonishing accuracy, whether we are measuring the behaviour of electrons in atoms or the vibration of something far larger. If the universe behaved in a fundamentally classical way, if collapse were a physical law, we might expect quantum mechanics to fail or distort at certain scales, but it does not. It behaves as though the quantum description extends seamlessly into all realms. Many worlds embraces this continuity, suggesting that the wave-like nature of reality never stops, never shatters, never needs a moment of collapse to make sense. It's important to note something with humility. None of these experiments prove many worlds. They simply allow for it. They open the door, invite the imagination to step through, and whisper that the universe may be far more layered and expansive than our senses reveal. The absence of collapse signatures, the persistence of superposition in larger systems, the behaviour of quantum computers, All these threads weave a picture in which many worlds remains a compelling, elegant possibility. What we have, then, is not a verdict but an invitation, a chance to see the universe not as a single path but as an ocean of potential, with our conscious experience tracing one gentle wave upon its surface. Whenever you're ready, we can continue drifting into the next session, exploring how scientists sometimes model the quantum world with ideas that resemble many worlds, even if they don't require actual parallel universes to exist. As we drift further into this soft landscape of possibilities, a gentle truth emerges. Even if we cannot peer into other branches of reality, even if we cannot test many worlds directly, scientists have not stopped trying to understand the deeper structure hidden beneath quantum behavior, and in doing so they have created models, thoughtful, imaginative, and sometimes surprising, that brush against the edges of the many worlds idea without requiring that countless universes literally exist. Tonight, we explore these ideas gently, letting them unfold like lanterns drifting across calm water. No equations, no sharp boundaries, only quiet images to carry us through. Let us begin with something called the many interacting worlds approach, often shortened to MIW. Despite the name, this theory does not claim that actual parallel universes exist. Instead, it suggests something subtler, that quantum behavior might be understood as if many nearby worlds exist, worlds that interact not physically but mathematically. Imagine a line of dancers moving across a stage in near-perfect synchronization. They are not separate universes, not separate realities. They are simply positions in a numerical model. When they move, their motions influence one another, creating patterns that look, from a distance, like waves. In the MIW view, quantum phenomena, superposition, interference, tunneling might arise from the subtle interactions of these imagined dancers. The worlds in this model are not real places. They are points in a simulation that help researchers visualize quantum behavior. Think of a violin string. When you pluck it, the vibration takes many possible shapes. Some shapes are tall, some are narrow, some are gentle ripples moving across the string. These shapes are not separate strings. They are different patterns in the same string. MIW takes this kind of idea and applies it to the entire universe, suggesting that what looks like a particle moving through multiple possibilities might simply be the result of many virtual configurations interacting with one another. In this view, quantum mechanics becomes less mysterious. There is no collapse. There is no need for a special role for observers. The dance of imaginary worlds creates effects that mimic the branching we see in many worlds, but without requiring that countless new universes physically come into being. It is a mathematical trick, but a surprisingly powerful one. Of course, this model raises a quiet question. If the worlds in MIW are not real, then why do they behave as though they are? Why does this approach reproduce the same patterns we see in quantum experiments? To understand this, imagine using tiny droplets of water on a vibrating plate. The droplets bounce up and down, creating ripples. Each droplet influences the others through the ripples on the surface. From above, the pattern becomes intricate, as if each droplet is responding to a complex field of possibilities. And yet, there is no field, only the water. The pattern emerges naturally from their interactions. MIW proposes that quantum behavior may emerge in a similar way, from interactions between imagined worlds that are never observed directly. This idea does not replace many worlds. Instead, it offers a way of understanding quantum phenomena without needing to commit to infinite realities. For some researchers, this is comforting. For others, it feels like a bridge, a way to understand how branching could work even if we cannot observe it. But MIW is not the only idea that brushes against many worlds. Some researchers explore something called quantum trajectories, imagining that particles follow many potential paths, each weighted by how likely those paths are to occur. Instead of collapsing into one outcome, the particle's behaviour is shaped by all possible routes it could take. This idea echoes the branching picture, but again, it does not require physical branches, only the gentle influence of might be and could be. Here, a useful image is that of hikers in foggy mountains. When the fog is thick, each hiker sees only a few feet ahead. They choose their steps based partially on instinct and partially on the terrain beneath them. Many possible routes exist, but the hikers feel guided by a mixture of their position and the shape of the land. In quantum trajectories, particles seem to move as if guided by a landscape of possibilities, even though only one route becomes the experience in the classical world. Some physicists also explore what they call pilot wave theories, where each particle is guided by a softly undulating wave that contains all the possible outcomes. This wave spreads through space like a faint shimmer on water, and the particle moves in response to it. There is no splitting here, only a delicate interplay between the wave and the particle, and yet the wave carries within it all the paths the particle might take, much like many worlds carries all the branches the universe might follow. These ideas show us something important. Many worlds is not the only way to think about quantum behaviour, but it is one of the most elegant and one of the most sweeping. It does not require hidden variables, collapsing waves, or imaginary worlds. It simply says, let the wave evolve. And in doing so, it gives us a universe where possibility is never destroyed, only divided. Quantum technology also offers hints that point toward a broader picture. Quantum computers, for example, operate by allowing many potential states to coexist for small periods of time. These machines rely on the same superposition that lies at the heart of many worlds. When a quantum computer processes information, it does so by exploring a space of possibilities simultaneously. Some researchers describe this as the machine feeling multiple paths at once before decoherence nudges it back into a single outcome. In the many worlds picture, this becomes even more poetic. The computation feels like many versions of the machine exploring different possibilities across different branches, with the final answer emerging as the thread that decoherence reveals to our branch. Again, this is not something we can test directly. It is a metaphor, a way of thinking about what quantum computation means. But even metaphors carry weight. They help us sense the enormous difference between a world that collapses and a world that branches. In a collapsing universe, possibility vanishes the moment it is resolved. In a branching universe, possibility continues, unfolding along paths you will never see. And models like MIW show us that even physicists who are cautious about branching still feel drawn toward interpretations that allow quantum phenomena to arise from multiple simultaneous states. As we move toward the close of our journey, the scientific landscape becomes less about proving many worlds and more about appreciating the quiet clues scattered throughout quantum mechanics. The clues that hint at a reality far more layered and intricate than the surface suggests. Whenever you're ready, we can continue gently into session 16, a soft look at where science stands today, how physicists think about branching, what debates still echo through their discussions, and why many worlds remains one of the most astonishing and strangely comforting ideas in modern science. As we arrive at this next quiet stretch of our journey, it's worth pausing for a moment to take in the landscape we've been walking through. Quantum mechanics, with all its shimmering uncertainty and soft branching possibilities, is not just a set of rules in a textbook. It is a living conversation, an ongoing dialogue among physicists, philosophers, engineers, and anyone who has ever looked up at the night sky and wondered how reality truly works. And in this conversation, the many worlds interpretation has gradually moved from a strange, fringe idea to a serious contender, one that thoughtful scientists discuss with curiosity rather than dismissal. To understand where science stands today, imagine a long wooden table in a quiet library. Around the table sit researchers from different generations. Some hold tightly to the older perspective, believing that the universe must collapse possibilities into one reality whenever a measurement is made. Others lean toward the gentle idea that the universe never collapses, that it simply evolves smoothly, carrying all possibilities with it. And many others sit between these views, exploring new ways to stitch together the mathematics, the philosophy, and the experiments surrounding quantum mechanics. One thing unites everyone at the table: quantum mechanics works. It predicts experiments with extraordinary accuracy. It explains the behaviour of atoms, electrons, molecules, stars, and the delicate machinery inside your own cells. The challenge is not whether the theory works, it is what the theory means. And that is where the interpretations diverge. To see how scientists view many worlds today, imagine a soft gradient of colours instead of a sharp dividing line. At one end are the physicists who still hold to the older classical viewpoint, preferring the idea that the universe collapses into a single outcome when observed. They may feel that branching is too extravagant, or that introducing countless unseen worlds is too heavy a cost for avoiding the concept of collapse. They are not opposed to elegance. They simply find comfort in the idea that reality is singular, unified, and succinct. But as we slide along the gradient, we meet a growing group of physicists who see something compelling in Everett's idea. Many influential researchers now speak of the universal wave function, the smooth, evolving description of all quantum states, as if it were the most straightforward version of reality. They argue that the rules governing quantum behaviour do not break down when we look at larger systems. They do not require an observer. They do not require special exceptions. They simply carry on, flowing like a river that never stops. These physicists find many worlds beautiful in its consistency. It does not add extra rules. It does not draw an invisible line between the quantum world and the classical world. Instead, it treats everything the same, from electrons to human beings to galaxies drifting in cosmic silence. In this view, the universe feels like a grand tapestry woven from branching threads. None of the threads disappear, they simply drift apart. Continuing along the gradient, we meet those who explore interpretations like decoherence-based views, pilot wave theories, and the many interacting worlds model. These scientists don't necessarily commit to literal branching worlds, but they agree with an important part of the many worlds picture, that quantum behaviour arises naturally from smooth, uninterrupted evolution. They argue that if you follow the mathematics faithfully, collapse is not needed, and while they might give different explanations for how outcomes appear singular, each of their perspectives keeps many worlds within arm's reach. It is here, in this broad middle ground, that many worlds gains a quiet strength. It is not embraced as a proclamation, but as a possibility, one that sits comfortably within the mathematics and gently answers the question of why quantum experiments behave the way they do. Now imagine moving further along the gradient, to the far end of the table. Here sit physicists who see Everett's idea not just as plausible, but as the most natural interpretation of all. They look at the universal wave function and say, this describes everything. Why add collapse? Why add extra rules? They see the branching of the universe as the unfolding of a grand, fluid structure. They look at decoherence and see the mechanism by which branches gently drift apart, each carrying its own version of events. They do not claim that branching is extraordinary. They claim it is ordinary, that the universe splits with every quantum event, not because it wants to, but because that is simply how the mathematics works. This group does not believe in many worlds because it sounds exciting or mysterious. They believe in it because it offers an astonishing simplicity. It takes the equations exactly as they are and asks for nothing more. It relies on no collapses, no hidden decisions, no special observers. It doesn't elevate human consciousness to a cosmic role. It just lets the universe evolve. And yet, despite this growing acceptance, no consensus exists. For every physicist who embraces many worlds, another prefers a different interpretation. Some cherish the mystery of collapse because it keeps the world grounded in a singular structure. Others avoid branching because they find the idea emotionally or philosophically overwhelming. Still others remain agnostic, comfortable with uncertainty, content to explore without choosing sides. This diversity is not a weakness. It is a reflection of the remarkable depth of quantum mechanics. The theory says much about what the universe does, and very little about how we should interpret what it means. And in this space of open-ended meaning, many worlds stands as one of the most imaginative, most elegant and most provocative ideas we have. It invites us to see reality not as a single line, but as an expanding tree of possibilities. It suggests that every quantum event, every vibration of an atom, every flicker of light, carves new branches that drift gently away from one another. It leaves a room for countless stories to unfold, countless versions of events to play out, countless versions of you to continue living in worlds forever beyond your reach. And yet, it grounds all of this in mathematics as solid as the floor beneath your feet. As we sit with this idea, a gentle reflection emerges. Perhaps reality is richer than the stories we grew up with. Perhaps the universe holds more than one narrative, more than one outcome, more than one you. And whether or not many worlds is ultimately the true description of reality, it offers a perspective that broadens the imagination. It turns the familiar world into something wider, softer, more intricate. It reminds us that possibility itself may be woven into the fabric of existence. Whenever you're ready, we can drift into the final stretch of our journey, a calm reflection on the version of you who listened tonight and the quiet beauty of living one thread of a vast and branching universe. There is a moment, gentle, almost invisible, when a long journey begins to settle into the quiet of reflection. As you sit here now, perhaps lying back or resting your head in a familiar space, you carry with you the traces of everything we have drifted through. The shimmering strangeness of particles that behave like waves, the soft branching of possibilities, the subtle question of who you are when the universe may hold many versions of you. And now, as we reach the final part of this exploration, the focus narrows back to something simple and personal, the story of the you who chose to listen tonight. To arrive here required countless steps, some so small you may not remember them, a casual search, a moment of curiosity, a quiet evening when your mind was open to wandering through ideas that stretch beyond the visible world. Each of these moments is like a soft nudge, guiding you down this particular branch of your life. And whether or not many worlds is the true shape of the universe, this version of you, the one breathing in this moment, is perfectly real, perfectly grounded in your own unbroken thread of experience. Imagine your life as we described earlier, a long tapestry woven from memories, choices and events that have gently shaped who you are. Up close, the threads are intricate. They twist around joyful moments, stretch across difficult ones, and gather in places where you learned, grew, or shifted direction. From afar, the tapestry looks whole, one continuous design that only you can fully understand. This is your identity, your story, your sense of self moving faithfully through time. But consider, just for a soft moment, that this tapestry might be one among many, that each decision you made cast a faint ripple into the larger structure of reality. In some distant, unreachable branch, a different version of you turned a different corner in life. Maybe they chose a different career. Maybe they moved to a different city. Maybe they laughed at something you frowned at, or stayed quiet where you spoke up. These possible selves, if they exist, carry their own stories, equally rich, equally vibrant, equally meaningful, yet none of them diminish you. Your place in the universe is not made smaller because other versions might exist. Your experiences do not lose their weight because other outcomes might unfold elsewhere. What you feel, what you think, what you remember, these are yours. The thread you walk is unique because you are the one living it. Even if the universe holds countless versions of events, this moment belongs only to you. Think of a vast forest filled with tall, ancient trees. Each tree has countless roots spreading beneath the soil, each root twisting in a different direction. Yet when you lean against one trunk, feel its bark under your hand, listen to the slow creak of its wood, you are connected to that single tree, even though the forest stretches far beyond your sight. The many worlds interpretation is like that forest, immense, intricate, branching endlessly. But your life is the tree you're leaning against. It is the one you touch, the one that holds you, the one whose story you feel with every breath. In this branch of reality, you chose to listen. You allowed your thoughts to wander through the quiet territory of physics and possibility. You opened your mind to ideas that stretch the imagination and soften the boundaries of what we think reality should be. Perhaps you felt curiosity or calm or wonder. Perhaps a question lingered in your mind or a memory surfaced unexpectedly. All of these experiences, subtle and personal, belong entirely to you in this thread of the universe. If the many worlds interpretation is true, then every possible version of you exists somewhere. But the version of you who listened to this gentle exploration tonight is the one who lives in this world, with this chain of memories, with this perspective. And that makes this moment meaningful. It makes it yours. There is beauty in imagining other versions of yourself living out other possibilities, but there is even greater beauty in recognizing the grace of the life unfolding right here. You do not need infinite branches to add significance to your story. Your choices, your emotions, your presence carry their own quiet weight. They ripple through the people around you. They shape the space you inhabit. They form a continuous thread that stretches from your earliest memory to this moment and beyond. If many worlds is true, it means the universe is generous. So generous that it holds every story that nature allows. It does not discard possibilities. It does not silence paths not taken. It lets everything unfold, quietly and endlessly. And within that vast generosity sits your story, not drowned among infinite others, but simply one thread among many. Stable, real, and deeply personal. Imagine, for a last soft moment, the universe as a woven fabric stretching out in all directions. Each branch is a thread, each thread part of a larger design. Some threads shimmer brightly, reflecting big events or dramatic turns. Others glow more subtly, carrying small moments of peace, quiet decisions, and evenings like this one, when you pause, breathe, and let your mind drift through an ocean of ideas. In this moment, you are holding one of those threads gently between your fingers. It vibrates softly with everything that brought you here. Soon, sleep may come. You might feel your thoughts loosen, drifting like petals on still water. And when you drift into sleep, you will slip naturally into another version of your world, a dream version, shaped by memory and emotion rather than physical events. This too is a kind of branching but quiet one, happening inside your own consciousness rather than across the cosmos. Whatever world your mind carries you into when sleep arrives, that world will be yours as well, woven from the same consciousness that listened here. And when you wake, the thread of your story will continue, carrying forward everything you choose to take with you from this moment. In all the vastness of possibility, in all the branching paths reality may hold, the version of you who reached the end of this journey tonight is uniquely here, uniquely present, uniquely real within your own experience. And perhaps that is the quiet miracle at the heart of many worlds, that even in an infinite tapestry, your single thread still matters, it still glows, it still carries you forward. When sleep comes, may it carry you gently into whatever world your dreaming mind creates, and may you wake resting in the knowledge that your story continues, beautifully and unmistakably yours.